Yep. So it is 3-8 to 3-12. It is 17 questions. Most of them are multiple choice. The non-multiple choice comes from your graphing and one of the inverse ones. We started 3-8. So 3-8 and 3-9 were on your quiz, which I still have makeups to give. I'm hoping to be able to get that back to you tomorrow. And that was your tangent and your inverse. Those were both on the quiz. So in the tangent topic, you're going to have to find the tangent of the unit circle angles. This is where I would make sure I memorize, right? Like our tangents at our axes. On the right it's 0, on the left it's 0, on the top it's undefined, on the bottom it's undefined. I would make sure I memorize those so I don't have to do any y equals x. And then every over 6 has what coordinate point? Root 3 over 2 and 1/2, and that would have what tangent? Root 3 over 3. Every over 4 has what coordinate point? Root 2 over 2 and root 2 over 2, and the tangent would be 1. And every over 3 has the coordinate point? 1/2 root 3 over 2, and the coordinate point, and the tangent would be root 3. So it could pull from any unit circle angle and ask you flat out just the tangent of it. Those should be your time saver questions. Should take you 10 seconds. Then we had a question where it gave you the endpoints of a terminal angle and you had to find tangent. Literally put y over x. That also should be a time saver and a free gimme point.
That was like your slope line, right?
Correct. It could say slope of the terminal line, or it could say find the tangent. Those mean the same thing. You put y over x. Do not overcomplicate that.
Wait, by that, do you mean they're going to give us like a circle?
It's not even a picture. It's just like words. It says the terminal point ends in blank, and you put the y over the x. Yep. And then find the graph of tangent. I'm going to come back to this because I put all the graphs together at the end. But that will be one of your, you'll either get tangent or cotangent. So I gave you either a sine or a cosine. I gave you a tangent or a cotangent. And then I gave you the secant or the cosecant, whichever one you didn't get the first time. So if you got sine, then you're going to get secant, so you have to graph cosine. If you got cosine, then you're going to get cosecant, so you have to graph sine. If that makes sense. Okay.
Is it going to be like really like a time crunch, this test?
I would say if you know what you're doing, you should be good. But if you're the one fumbling over graphs, that's where it's going to kill you. Yeah. Yeah. They're not word problems like they were, so the reading of them shouldn't take forever. If you know what you're doing, you should be fine. But if you fumble over the graph, that's where you're going to hurt yourself.
So what do you mean?
Like not know how to do it and take forever to try to graph. Yeah, finding your key points, all that stuff, your asymptotes. Okay, so now we get into the inverses, and I would say this is where it gets tricky in what you're reading. You have to really pay attention to, is it looking for sine -1? Is it looking for sine of x equals? Because remember, you have to restrict your things differently. The good thing is these are multiple choice. So hopefully when you look at your answers, you don't mess yourself up. Like with the interval, do you add the interval? Do you not add the interval? Do you restrict it? That kind of stuff is what you've got to pay attention to. The graph, I went light-ish on the graphs of the inverse. You're not hand drawing a graph of an inverse. You have to be able to identify it from a multiple choice question. So you need to know what the parent function looks like. And then you would need to know how to transform it, whether it's a vertical dilation, a horizontal dilation, a shift, that kind of stuff. And then under this says find the inverse using an equation, which was on your quiz. And that one we had to alter the domain and range. That you're going to see again. Yeah.
Wait, what?
So arc sine is the same as sine -1.
Correct.
So we can see either of them?
Correct.
So what about the questions on sine is equal to x? What did you say about those?
Like sine of x equals, that's where you use the full unit circle and you add your 2n pi like that. Sine -1 says you have to restrict your unit circle to just the right side.
So if I have like sine, like arc sine x, then there's no 2n plus, there's no.
Correct. And you only use negative pi over 2 to positive pi over 2. Yeah.
What do you do again if we have like a solve for the equation? We have like a
number inside,
Yeah.
like a multiple angle. We're gonna get to those. Those are.
Like not the one we did yesterday though.
Yeah, no, we'll get to them. I promise. Yeah, yeah. All right, so let's talk about what these look like. Remember the sign, like, I don't know if we did it in here, but like for me, I try to remember like sine is an S, and it makes that S shape. It starts here and it ends here. So if I start here and I cross through here, that's what my sine -1 graph looks like. It crosses through the x-axis because our initial domain is restricted from -pi/2 to +pi/2, which means our range is -pi/2 to +pi/2. And our domain goes -1 to +1. So you would have to spot, like it would say, which of the following is 2 sine -1. And you'd have to know that that's that shape, but stretched vertically. The domain and range is not on that question. It comes back later, though. The cosine lives above the x-axis, right? Because we restrict it from 0 to pi. So our range is 0 to pi. Our domain is the same, -1 to 1. But it happens above. It goes like this. Yeah.
You said like for these questions, it'll be the graph and then another type of question?
Yeah, which is after this. I'll show you. Yeah.
Okay.
They were both on the quiz, though. And then the tangent's the one that's kind of different. It's turned sideways. It crosses through pi, crosses through 0, 0. It has a vertical asymptote at pi/2 and -pi/2. Good morning. Thank you. So it looks like that. Our domain is all real numbers. And our range goes -pi/2 to +pi/2 with a parentheses on them, because the asymptotes, it can't include it. So if it said 3 sine -1, that's a vertical stretch on the y's on sine. I would go up to 3 and down to up to 3 pi/2 and down to -3 pi/2. If it was something like cosine 1/2 -1, now that's a horizontal stretch by a factor of 2. So you have to know your transformations, okay? But it is multiple choice.
So if it's like 3 sine, that affects the domain, and if it's like
No. If it's 3 sine, it affects the range, because the 3 on the front would be a vertical stretch, and vertical means range.
And if it was like sine 2x, then it would.
Now it's horizontal, and it cuts your x's in half.
Okay.
Yep. Okay, then you have your inverse values. So this is where it could say sine -1 or arc sine, cosine -1 or arc cosine, tan -1 or arc tan. They mean the same things. And these will be unit circle values. It could be like something like √3/2. It could be something like -1/2. It could be something like -1. Those are all going to be unit circle values.
Wait, it won't be like pi/6.
The answers to these are angles. So this time you're given the trig function, your answer's the angle, right? But the catch here is the restriction. So we restrict based on our original, like if you come back here, the range of these is how we really restrict those curves. So the sine and the tangent only come from the right side of your graph. And we use the negative angles. This is sine and tangent. And in the fourth quadrant, we don't use the positives, we use the negatives.
For everything.
For sine and tangent. For cosine, you use the top, 0 to pi, your natural angles. Remember, there's only one answer to these. So if I said tangent of x equals -1 and I want to solve the equation, there are 2 answers to that question. If I say tan -1 of -1, there is 1 answer, and it would be -pi/4. Yeah, so if the question is tan of x equals -1 and it says solve on the interval of 0 to 2 pi, then I use my full circle, and that answer is 3 pi/4 and 7 pi/4. If it says tan -1 of -1, that answer is only -pi/4.
So if it just says tan, you're like finding it like normal. right?
Tan, you use the circle. Yep, only the negative ones or arc tan. Those are where we
Because
restrict
that's a
it.
different graph.
Correct. Because you have to restrict it so it passes your horizontal line test, right? The inverse are restricted because it has to pass the horizontal line test. If we don't restrict it, it doesn't pass the horizontal line test, and then it can't have an inverse.
So if it said something with the cosine and the sine and it didn't have the negative one?
You're using the full circle.
Yeah.
Yep.
And then what are the points for the restricted circle again? For like cosine?
Like the angles, you mean?
Yeah.
So you go 0, pi over 6, pi over 3, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. That's what you meant?
Yeah.
Yeah. Top of the graph. Yeah.
Will we have any ones like the first one on our test? Or?
Yeah.
Oh, no.
That's what's hard. This had equation solving and inverse.
Mhm.
Yeah. To be honest, all these topics are in the pre-calc honors advanced class, but they're in 2 separate chapters.
Oh.
Yeah. Yeah. It's where AP's gonna get you. Remember, cumulative. It's cumulative no matter what.
Yesterday we were doing something and then you were saying that you had to read it specifically because you could solve it like it depends
The
on
2x.
Is
Yeah,
that
yeah,
what it
yeah,
was?
yeah. When it's mixed in 2 different trig functions, you use the double angles, but when it's by itself, you would do the multiple angle, which I'll show you when we get there. Yeah.
Based on our grades, how ready do you think we are?
I have no idea.
But like,
Nobody knows that answer.
do you think?
I think the people who wrote the test don't know that answer.
I think I'm ready, Miss Kristen.
You're not gonna throw it. All right, so find the inverse of the function. This is where you will get an equation. You'll get something like f of x or y equals 2 cosine of x. And you have to find the inverse. So we switch the x and the y. And we solve for the new y. So I'd multiply by 1/2. And then we cosine -1 both sides. And then, I think only one person did it on the quiz, but you have to remember to put the f -1.
Do we ever get those back?
No, I'm still waiting on a couple people and somewhere in this room to take the makeup. If it doesn't happen today, then you will get them back tomorrow, and I will make a new
I was
makeup.
gonna say if you have it, they don't do it today, I can't see
No, I'd love to, yeah. Okay,
Wait,
so,
what is it? Oh, never mind. Sorry.
you good?
Yeah.
So most of you got that part right, I would say, on your quiz. There wasn't a lot of mistakes there. What did happen that there were mistakes on is the domain and range shift. Remember, now we're going on the new inverse equation, and we're saying what shifts happen so that we can adjust the inverse domain and range. So if there's a 1/2 inside, what does that cause? A horizontal dilation by a factor of 2, which means what changes your domain and your range? Good. Your domain changes because it's an x. Anything inside the parentheses affects your x, right? Horizontal is your x, which would affect your domain. God bless you. Now the domain of cosine's inverse, or cosine -1, is -1 to 1. The range is 0 to pi. Think about your little graph, right? It all lives above the x-axis. It goes from -1 to +1. So a horizontal stretch by a factor of 2 means I'm going to take my x values and I'm going to double them. So my domain changes to -2 to 2. My range would stay the same. Your range is going to shift with a vertical stretch, so something on the front, or a vertical shift, so adding at the end, or a negative on the cosine because it would flip your signs. Yeah.
So if we're finding the domain or range of the inverse function, we stretch after we shift, right? I mean, we
You stretch, then shift. Yeah. Remember, like you wake up in the morning and you stretch before you get up out of bed. You stretch before you move. Maddie, if there was a negative on the front of the cosine, it would be a reflection over the x-axis. Right? It flips it upside down, and that's going to change your y's. So
What if it was on the inside?
then it's a horizontal over the y-axis. Yep, and that changes your x values. You just multiply your x values by -1.
So is
Yeah. If the question was tan -1 of -1, so inverse tangent or arc tan of -1, then that answer is -pi/4. not 7 pi over 4, which is the same angle but a different name. You have to restrict it because it's an inverse. So A might be this one, B might be 7 pi over 4, and if you pick it, it's wrong. You have to pick the negative angle for the inverses. Yeah.
And the reverse, like cotangent, you would flip it, right?
Yep. Oh, so reciprocal, which we'll get to. Those are in the next section. Yeah. So 3/9, yeah. So 310 was where we started solving our trig equations. And again, you got to really pay attention to your instructions. If they just say solve, or if they don't have a -1 over the arc, now we do it a different way, right? We solve using the full unit circle plus 2n pi for sine and cosine. And we solve using the top of our unit circle plus n pi for tangent. So if you're given the interval, you use the full circle. If you're not given the interval for sine and cosine, you use the full circle and you add 2n pi. And for tangent, you use just the top. So quadrant 1 and quadrant 2, and you add n pi. So think tangent top. But that's for solving, that's not for the inverses. That's where I think it's confusing. Okay, so now, and then you get into like, obviously this was all the solving, something like this, where you're going to solve for the cosine. It would be cosine's -1/2, and then you would look at your circle, and you would find everywhere cosine is -1/2. We know how to do those, right? Okay, yeah.
What's Q1 and Q2?
Quadrant 1 and quadrant 2. That's what you use for tangent for the top.
Okay.
Yeah. The multiple angle ones, or the altered period ones, is how the AP refers to them, are the ones that are not just an x on the inside, right? They either had something multiplied by the x or they had something divided by the x. Don't confuse these with like a tan 2x equals -1, and then try to use your double angles, right? First of all, we didn't do tan 2x, but even if it said sine 2x, you don't have to use your double angles here. You will just solve this equation. So I'm going to find where tan is -1, and we just said that happens 2 places on my unit circle and my natural unit circle, because this is not inverse. So it happens at 3 pi over 4, and it happens at 5 pi over 4. Oh, but the interval won't be given. It's 3 pi over 4, just 3 pi over 4, plus n pi. But that's 3x, not x.
So there is an interval, there isn't an interval.
On the multiple angles, I will not give you the interval because it makes it harder.
Wait,
We add n pi, but it's not 3x. I mean, it's not just x on the left side. It's 3x, so we would divide by 3 or multiply by 1/3 on both the interval and the angle.
Are you gonna go over like when we have to do the k plus 2 and I think
That's this. Oh, for the graph? Yeah, yeah.
Okay.
Oh my, I can't do anything right now. Pi over 4 plus n pi over 3 is how that answer will be written. All right. Then came all the inverse functions, and in this section, we're just finding the inverses of the angles, and then came the graphs. So the inverse of the angles will look like this. So cosecant of pi over 3. So if you're worried about being confused between like sine -1 and cosecant, sine -1 is going to have a value inside, and the answers will be angles. Cosecant is going to have an angle inside, so your answer will be values. So like cosecant of pi over 3, I would go to pi over 3. Dear God, let's have this memorized by then, okay? And I would say, what's the sine at pi over 3? And it's 1/2, and then it's the reciprocal of that, which means it's not 1/2. It's I don't know why I listen to you. It's root 3 over 2. The coordinate point is 1/2 and root 3 over 2. So the sine is root 3 over 2. And I flip it. So I get 2 over root 3, and it gets rationalized to 2 root 3 over 3.
Wait, Mr. Chris,
Yeah.
cosecant to the -1.
No. No.
So you would never.
You're not mixing inverses and reciprocals. No.
What is, never mind.
I'm telling you, I'm a
Cosecant means?
Cosecant is the inverse of sine.
So we're finding the y and then just
Flipping it. Yep. If it had said secant, you'd find the x and flip it. If it had said cotangent, you'd have the tangent and you'd flip it. We good? Yes?
No, I never look at that.
Yes? Okay. Let's see. Okay. I grouped them together because sine and cosine are similar, and then tangent and cotangent are similar but a little bit different, and then I grouped together on the next page is secant and cosecant. I'm going to say it again. You are going to have either a sine or cosine. You are going to have either a tangent or cotangent, and then you are going to have either a secant or cosecant. If you get sine, you're getting secant, so you have to graph cosine. If you get cosine, you're getting cosecant, so you have to graph sine. So you're graphing both of those at the end. So sine and cosine actually came from the previous test, but we did not graph them as specifically as we are now. So you are going to find the amplitude. You're going to find the period, and sine and cosine's period is 2 pi over b. I would recommend find your key points doing the 1/4, the 1/2, and the 3/4. You're going to have 3.
I forgot how to normally graph.
So I would do the 1/4, 1/2. You just did it. We did it when we did 3/4. You would take the period. You're going to multiply by the 1/4, the 1/2. You did it to do secant and cosecant. You just did it. But we just didn't add in the asymptotes. So then I would plot these, and I would plot 0. And then the 4 key points. If it's sine, it starts at 0, goes up, down, down, up. If it's cosine, it starts at the amplitude. It goes down, down, up, up. Yeah.
So for the tangent graph, the bx minus c equals poverty, that's defined your asymptotes.
Correct.
You're adding the periods by the other asymptote.
Correct. So when you get to tangent, you find A because that's your quarter point and your 3/4 point, but it's not called an amplitude. You have to find asymptotes here. So we set what's next to the tangent, whatever's in the parentheses, bx minus c equal to pi over 2. And then that's your middle asymptote. So when it asks you to give the asymptotes, you give that one plus the period. So in the normal cases, the period is pi k, or pi, sorry, so you do pi k. If not, you're going to adjust the period. And then cotangent, remember, and the shape of tangent goes up, right, down, left. Cotangent's difference is it goes up, left, down, right. And you set the bx minus c equal to 0, and that's your first asymptote. Then you add and subtract the period from that to get the other 2. And if you are to put your asymptotes on a line, which it's going to ask you to do, it's going to ask you for asymptotes and domain, then you would do x equals the first asymptote plus the period times k. So period times k. And this is first asymptote. That's the same for cotangent and tangent. And domain would be all real numbers except those, okay? And range for cotangent and tangent is all real numbers because it points up and down. Yeah.
for cosecant and secant, we need to draw the regular sign.
Yeah.
For cotangent, do we need to draw the regular
No.
sign? Okay.
No. Yeah.
What's K?
K is just your constant. So if you're giving all of the asymptotes, so there's going to be a line that says, give me the constants.
Oh, okay.
Then you do the period times k. You find the asymptote plus the period times k. Yep.
So, it probably just said this, but K is your period.
No, the pi in this case is the period. The k is just your constant. You're just saying, because when it asks for asymptotes, it means all the asymptotes of this graph. So it's the one you found first plus, for tangent and cotangent, plus the period times k. Because it just continues every period.
So, I would put the period in for pi.
Correct. Which on a parent function of tangent and cotangent period is pi. It's just if there's a different b. No, if there's a different b, it's pi over b. So this would technically be your first asymptote, which is 0 on the parent function, but it could be different. And this is the period, which on your parent function is pi, but on everything else would be pi over b.
Oh, okay. And then I just leave K there.
Okay, always goes on the end there.
Okay, and then what do I do for,
So now, let me just do these and then I'll go back, okay? So now cosecant and secant graphs. These are where you're going to graph sine and cosine. And then everywhere there's a 0, you put an asymptote, and then you bounce your parabolas off the top and the bottom. What's important here is to make sure you understand where the asymptotes happen. On the cosecant curve, which is based on your sine function, the first asymptote happens at 0. Or the first key point if there's a phase shift. And then what's different from this one in tangent and cotangent is we add half the period. Because there are 2 asymptotes to every sine curve, and there are 2 asymptotes to every cosine curve.
Have we even graphed these?
Yeah, that was all of 311.
Interesting.
Yeah.
I don't remember that.
And then secant, you're graphing it based on cosine. So it starts at 0, it comes down, it goes back up again, which means your asymptotes, the first one happens at the quarter point. And then you add 1/2 the period times k.
There was just so much in 3
I know.
I just
And then obviously you have to do your domain and range. Domain is going to be all real numbers except where the asymptotes are. And your range, remember, it bounces. So if it does this and this, and let's say this is -1 and 1, my range goes from -infinity to 1 to -1, and then 1 to positive infinity. Yeah.
What is 1/4 PT?
That's the 4th quarter point. So like the key point you get by multiplying by a 4th. This should not be. This part here? Oh, this. Yeah, quarter point.
Okay.
Because for cosine, right, it looks like this. I need to know this point.
Because that's where the first.
Because that's where the first asymptote happens. And then it happens every half period after that.
Will we always have a graph for that and we can just see it or no?
No.
Oh.
You're going to either have to graph it or you're going to have to, like, visualize it. Yeah.
Why don't I remember graphing these? Like, that's actually a problem. Like, I feel like
You, like, black out? Yeah. Oh, maybe you weren't here, Michelle?
There was so much.
There was a day you weren't here.
Yeah, but I learned everything.
Okay. This is 312. So 312 is your Pythagorean identities. Again, please, for the love of God, memorize these. If you're trying to decipher them, you're wasting your time. Like if you're trying to derive them, you're wasting your time. And then your sum and difference. So the pattern for sine is what? Sine, cosine, cosine, sine. So this would be sine of x, cosine of y. And the sign stays the same. Cosine of x, sine of y. I should have zoomed in so I don't run over. So the sine of x minus y is sine of x, cosine y, minus cosine x, sine y. And then the pattern for cosine is cosine, cosine, sine, sine. So cosine x, cosine y. Change your sign. Good. Sine of x, sine of y. This would be cosine x, cosine y, plus sine x, sine y. I feel like sum and difference, if you know what you're doing, should be pretty straightforward. It's not going to trick you, okay? It's going to say, find the sine of pi over 3 plus pi over 4, and you have to use the formula. Or find the cosine of pi over 3 plus pi over 4, and you have to find the formula. That's it.
So that's just like memorization?
Yep. And then obviously you have to know what happens at each of your unit circle angles because then you got to plug those values in. But yes. And then the last one was your double angle. So your double angle is going to be built into either the verifying, well, both, the verifying and the solving of the equation. So if it said sine of 2u, memorize 2 sine cosine because it will make your life easier. If it says cosine of 2u, remember there's 2 options, cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. For me, what helps me remember which one comes first here is that C comes before S. So the cosine one goes before the 1, and the S comes after the 1. So like that's how I memorize it. Yeah. Please look into my face. Look at me, people. You have to start this review tonight. You have to. There's no option. Tomorrow you're going to